Welcome back, and let's continue with the same file from where we left off. So till now we have discussed the volume speed attributes of the emitter type volume, and we have also worked with the volume emitter attributes with the volume shape as a cube. Now let's change the volume shape from cube to the cylinder, and you notice now we don't have the access to away from center attribute because this attribute works with the cube and the sphere. In sphere and cube we have away from center, whereas in cylinder, cone and torus we have away from axis. Alright, so let's focus with the volume shape as a cylinder, and let's play the timeline, and you can see that more or less the behavior is the same. But let's do one thing. Let's study the attribute first, that is away from axis. Let's disable the other attributes. And now if I play the timeline, you can see these particles are now moving away from the overall shape of this volume, that is a cylinder. And these particles are moving away from the central line of the axis. Let's do one thing. Let's scale this a bit more so that it would be much easier for us to visualize. And now let's play the timeline. Alright, so you can imagine we have a central line running from the central axis of this volume, and particles are moving away from that. Now let's do one thing. Let's rescale everything, put it back to the 1, and let's increase this a bit more from the y-axis. Fine. And now rotate this. I just wanted to create a simple effect of spark emission. Alright, so let's increase the away from axis value to the 3, and this will increase the overall velocity of particles. Alright, now play the timeline. Now particles are moving pretty fast, but if you see from this particular axis, you can see the particles are forming again a kind of a line. If I just shrink the overall size of the emitter, you can see now particles are creating a kind of a line, or some kind of a very noticeable and unrealistic pattern. So how are we going to fix this? Well, it also depends upon the type of the shot. In some situation this can be very useful, but as if for now we want to get rid of this straight kind of a pattern, so we can use the random directions. Alright, so with this the particles are now moving randomly. Alright, now let's do one thing. Let's enable the gravity. So under the nParticles shape node we have the dynamic properties. Let's use this options, ignore solver gravity, and we can also use the ground plane. So we want the particles to collide with the base of the ground. Let's add some bounciness to that also, and particle, once they're going to hit the ground, they're going to collide and they're going to bounce. Now let's play the timeline. Pretty good. And now you can notice the particles are also bouncing a little bit. And let's change the overall type of the particles. Well, first change the overall rate. The rate is very high. So under the particle emitter node we have the rate particle per second. This is really very high value. So let's change this to maximum 30. Alright, and now if I play the timeline, you can notice the particles have significantly reduced in their quantity. Now select the particles and change the overall render type of the particles from point inside the shading, from point to the streak. The overall size will increase automatically based upon the values of the velocities. So if we have higher velocities, the overall length of the particle will increase. Let's do one thing. Let's get rid of this tail fading by using the tail fade attribute over here and increase this to 1. So with this we have no more fading from the tail side. We can also manually increase the overall tail size by using this attribute, which is the tail size. So if I increase the size, you can see the tail size is now increasing. But let's do one thing. Let's leave the values of the tail size based upon the velocity values. And let's do one thing. Inside the emitter node, let's increase the away from axis value to very high value. And now you can see, if I just pause the timeline, you can notice there is a significant change inside the overall length of the tail size of these particles. Alright, now let's get back to the value of 5 maximum and play the timeline. Now pretty nice. So it seems to like the particles are getting emitted from this point, and they are creating a kind of a spark animations. But there is one another problem. And as you know, these particles, the particle type point as well as the streak, these all are the hardware render particles, and they will not going to support things like the textures or shading maps, or you can say the volume shaders of the Maya. So how do we going to incorporate the textures or shading map inside the particles if we wanted to change the overall shading of the particles? Well, that can be possible if we change the overall type of the particles from the hardware render particles to the software render particles. So right here we have the software render particles, and if I open this drop down, we have the particle ranges from multi-point till streak, and all these particles are basically hardware render particles. We have only 3 particles listed over here which supports the software rendering. If I change the type to the tube, you can see first of all there's a very big and gigantic particles are forming in our scene, so we'll get rid of this, not a problem. But there's very interesting attribute over here, that is S by W. Then it simply means it's software, it supports software rendering. Okay, so let's do one thing. Let's get rid of the big size of the particles while playing around with the value of radius 0 and radius 1. And radius 0 means the start length of the particles, and radius 1 is the ending of the particles. So let's change the value of radius 0 to, let's say, 0.025, and the bottom length, that is 0.025. Alright, so with this, now we are back again with the streak mode, and the good thing is these particles are software render. Okay, now if we wanted to render the particle type point, then what we need to do, we simply need to get rid of the tail size. So if I take the value from 1 to the 0, you can notice now the particles are again as a type point. So we can use both these type of the particles. We can use the streak, we can use the point based upon the value of tail size, and rest everything will going to remain the same. As you can see, once these particles are hitting the ground, they are losing their velocities, and now they are getting back to their point mode, because now the tail size won't be able to help them, since these are totally dependent upon the velocity. So the overall length of the particle is still going to be velocity dependent. But if in case you dip this value to the 0, now in this case the point will remain there from the start till the end. Alright, so this is very, very important. So that was just a very basic effect in creating the effect of a spark, and I hope you have understood this concept. So let's take a pause from this clip. Let's end this clip over here, and we'll begin with a new one. And I like to explore the another emitter type, that is the surface.